This function here provides us with a strategy that we use algebraically for finding limits to infinity. So we're not going to keep on doing this numerical analysis and putting in bigger and bigger x's, but we're going to use what we know about this graph y equals 1 over x. So could you put this into your notes? You just did it in the warm-up. Y equals 1 over x looks like this. And let's anchor it there. And we are going to look at the limit as x approaches positive and then the limit as x approaches negative infinity. Okay, so going to negative infinity, then I'm heading this way on my number line to negative infinity. What is happening to my y values? What is this limit as x approaches negative infinity for this function 1 over x? Well, my y values are getting closer and closer to 0. Yeah, they're always negative, but it's always getting closer to 0. Over on this side, what happens as my x values get infinitely large positive? That is, what's the limit as x goes to positive infinity for this function 1 over x? Once again, my y values are getting closer and closer to 0. Okay, and we've graphed the function 1 over x squared as well, haven't we? You guys remember what 1 over x squared looks like? I guess all of these, the 0.11 would be on there. This would go up faster. And what would happen to all of these negatives? Well, when you squared them, they would reflect up. So at infinity, negative infinity, that's going to 0. Positive infinity, that's also going to 0. So we use this over and over and over again when we're evaluating infinity polynomial functions especially. If we have a number bigger than 0, a rational number, then the limit as x goes to 1 over x to the power of r is also 0. And if r is similarly if it's going to negative infinity. So kind of think about this graph. Whether I squared it or left it like this, at positive infinity, it's still going to 0. Okay, so algebraically, we're going to keep on trying to substitute that into our equations. Okay, so over the page, and let's get some strategies here. So I'm going to write it down at the top, and then we'll look at how we implement it. For limit to infinity, that is, x is approaching infinity. Here's our strategy. We are going to multiply by 1 over x, and we're going to put some exponent on that. And how side of that exponent is this? You're going to look at the highest power of x in the denominator. It has to be in the denominator. Okay, so the limit as x approaches infinity, squared is 2 over 5x squared plus 4x plus 1. So let's evaluate that limit, and let's talk about the limits that we're using at each stage. I'm going to properties of limits that I'm using at each stage for this example. And after this, I don't expect you to keep on doing all. So I'll let you know what part you have to show when deviate. We're looking at the limit as infinity for this function, 3x minus 2 over 5x plus 1. And our stress denominator, and see what's the highest power of x appearing? X squared. So I'm going to take the top and the bottom and do the multiply by 1. This is the form of 1. 1 squared. Top and bottom. So I'm multiplying that limit. Not going to change anything. If I multiply each and every term in the numerator, each and every term in the denominator, this will turn into the limit approaches infinity 4. So I've got 3x squared times 1 over x. That's just going to give me 3. Minus x over x squared is going to give me 1 over. Subtract 2 times 1 over x squared, which will give me 2x squared. All divided by bottom. Tell me which. Okay, you're all getting 1 over x 5 squared gives me 5. 1 over x squared times x gives me 4 divided by x. 1 over x squared times 1 gives me 1 over x squared. Questions so far? Oh, here's the property that we're using. So we can actually split all these. You have the limit as x approaches infinity for the constant function 3. The limit as x approaches infinity over x. Subtract 2 times x approaches infinity for 1 over squared. Numerator. Here's your denominator. The limit as x approaches in the constant function 5 plus 4 times the limit as x approaches infinity for the function 1 over x plus the limit as x approaches infinity for the function 1 over x squared. There's your denominator. What to y is x approaches infinity for this function y equals 3. That's as x gets infinitely large, y. It doesn't change. The answer to that question is 3. You know the answer to this. What happens as x approaches infinity? Function 1 over x. 0. What happens as x approaches infinity? Function over x squared. 0. So, limit as x approaches infinity for the constant 5. 0. Still 0. Plus 0. The answer is 3 over 5. What does that mean? That is infinity 3 over 5. This corresponds for that. Sorry. Yeah, question here. Oh, was 2 times 1 over square. So it's like this is constant whole front and say it's 2 times. I factored out 2.